All right, let's just jump right in. You know that feeling when you're starting a new project? It could be anything, launching an app, planning a party, and it just feels like chaos, right? There are a million things to do, and it's so easy to get overwhelmed. But what if I told you there's a way to turn all that chaos into pure clarity? Today, we're going to break down the fundamentals of project scheduling. These are the tools that'll help you turn a messy list of to-dos into a clear, totally manageable plan.
Think about it this way. Any complex project is really just a giant jumbled puzzle. You've got all these different pieces, your tasks, your resources, your deadlines, and you have to figure out how they all snap together. It's not just about knowing what the pieces are. It's about understanding the sequence and seeing how they all connect.
Let's make this a little more real. Picture yourself in charge of this graduation event. Okay, so the stage can't possibly go up until the grounds are prepped. The sound system, you can't even test it until the stage is built and the power is on. And the food, well, that definitely can't show up until you have the tables ready to go. You see, every single piece depends on another.
And that right there is the million-dollar question, isn't it? A single delay could set off this catastrophic domino effect. So, how do you build a plan that's actually resilient? How do you create real order out of all this potential chaos? The answer? You need a process. You need a roadmap. A great project doesn't just happen by magic. It's guided through these distinct phases. It all kicks off with initiation. That's where the idea is born. Then comes planning, and, this is where we'll be spending most of our time today. That's followed by execution, monitoring, and finally, closure, where you wrap the whole thing up. This structure alone is your first big step out of the chaos.
So let's get right into the heart of planning. Before you can schedule a single thing, you've got to see how all the tasks connect. You need a map of your project's workflow. And I'm not talking about a simple list. I mean a visual representation of all those dependencies. And we build that map using something called a network diagram. The process itself is surprisingly straightforward. First, you just list out every single thing that needs to get done. Then you figure out the relationships. What has to happen before something else can start. Finally, you just draw it all out, connecting the dots to show the flow from the very beginning to the very end.
And here's a really classic way to visualize this, the activity on arrow diagram. It's just so elegant in its simplicity. See the arrows, the ones labeled A, B, and C? They represent the actual work being done. The circles, or nodes, are your milestones, the start or finish of an activity. It's a simple but really powerful way to see the logical flow of your project. Okay, so we've got our map, but a map without a scale is really just a sketch. We need to know how long each activity on our diagram is actually going to take. And we can't just guess, right? That's a recipe for disaster. We need a systematic way to deal with all the uncertainty of the real world. So let me introduce you to PERT, the Program Evaluation and Review Technique. This was developed by the U.S. Navy way back in the 50s to manage some incredibly complex projects. PERT is just a brilliant tool for estimating time. Instead of pulling one number out of thin air, it uses 3 different estimates to get to a much more realistic duration. Here's the breakdown. For every task, you come up with 3 numbers. First, you've got your optimistic time. That's your best case scenario, if everything goes perfectly. Then there's the pessimistic time. That's if Murphy's Law hits and everything that can go wrong does. And finally, the most likely time. This is your realistic gut feel estimate. So how do we combine these 3? Well, the PERT formula is a weighted average. But check this out. The most likely time is multiplied by 4. This is the clever part. It gives it way more influence, which anchors our estimate in reality while still respecting those best and worst case extremes. So for example, if our optimistic time is 2 days, pessimistic is 10, and most likely is 5, the PERT duration comes out to 5.33 days. It's a much more thoughtful approach than just a simple average, right?
And now, we get to the big payoff. This is what it's all been leading to. We've mapped our tasks, we've calculated realistic timings for each one using PERT, we've basically brought all the puzzle pieces to the table. So now it's time to put them together and find the single most important sequence in our entire project.
All right, let's put it all together now. With our tasks mapped out and our durations calculated, we can finally see how the whole project flows. Look, there are multiple paths to get to the finish line, right? One path might be ABD, another might be ACE. By adding up the PERT durations along each of these paths, we can find the longest one. And believe me, that's the one that dictates your project's timeline. And that longest path, that is called the critical path. And it is, without a doubt, the absolute backbone of your schedule. It's the one sequence of tasks that has zero slack, zero wiggle room. Any delay to any activity on this path will push your final deadline back by that exact amount of time. As a project manager, this is where you have to focus your attention.
This brings us to a really cool concept called total float. Float is, simply put, wiggle room. Tasks that are not on the critical path have some amount of float. They can be delayed a little bit without messing up the project's end date. But the activities on the critical path, they have zero float. None. And that's exactly what makes them critical.
So let's see how all this stuff actually builds into the tools you probably use every day. All this underlying logic, the network diagrams, the dependencies, the critical path, that's the engine that powers the most common project management visual there is, the Gantt chart. In a good Gantt chart, the critical path is often highlighted in red, so you can see at a glance which tasks you absolutely have to keep an eye on.
Now, it's worth mentioning that while we looked at that classic AOA diagram, modern tools almost always use the activity on node method. With this one, the tasks are inside the boxes, and the arrows just show the dependencies. This is the industry standard you'll find in pretty much all project management software, and it's the logic that actually builds out those Gantt charts.
So why did we just go through all this theory? Why does it even matter? Because understanding the critical path is what lets you use tools like Gantt charts effectively. It's what helps you decide where to put your best people, where you need to watch for risks, and how to track if you're really on schedule. It is the secret to transforming that chaotic puzzle into a clear, actionable timeline. Ultimately, you can think of the critical path as being like the keystone in a stone bridge. It's that one single piece that locks everything else into place and gives the entire structure its strength. If you know your critical path, you know your project. It's that simple. So there you have it. You've got the blueprint now. You have the tools to map your workflow, to estimate your timing, and to identify the tasks that matter most. The only question left is, what's the first project you're going to rescue from the brink of chaos and guide to a state of perfect clarity?